8.2. So here we have graph of polar equation. So graph of polar equation of r of f, a function of theta, consists of all points where at least one polar representation satisfies the equation. So what we're doing here is that instead of saying all points, if I plug in for given values of x, I produce y. Now I'm going to give values of theta, I produce r. Sometimes you give values of theta which produce values of r which produce theta. That's kind of like sometimes you get values of y which produce x. So for most of the time it's r as a function of theta. So what do we do to do this? So let's do it with kind of a very straightforward case. And so we're going to take our theta and we're just going to kind of spin it around the circle. And so here we're going to start at 0. Let me actually make my point a little bit finer for this one. So I'm going to start at 0. I'm going to do pi over 2. I'm going to do pi. I'm going to do 3 pi over 2 and then 2 pi. So that's plenty for this one. Well, what is r? Well, r doesn't care, right? R is just 3 regardless. And so my polar coordinates are the following. It's 3, 0, 3 pi over 2, 3 comma pi, and 3 pi over 2, and then 3, 2 pi. And so these are our points. And so let's go and plug them in. So here, 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 here. I guess I never found those 2 points, but I assure you they are at those points. And so here, r equals 3. What does this produce? It just produces a circle. Right around r equals to 3. Alright, so that produces a circle. So let's go ahead and so that's all there is to it. Now, it gets more complicated for sure. So let's start up top. So r is equal to something in a circle. So if r equals 2 is a circle of 2, r equals 1 is a circle of 1, r equals, 3.5 is a circle with the radius 3.5 centered at the origin. Okay, so let's look at thetas. Theta is equal to pi over 3. So in this case, theta is always equal to pi over 3. And I'll go ahead and just do 6 points. I think that's plenty. Alright, so here r can be, it could be 1, 2, 3, because that still satisfies this equation, as long as this is over here. So I'll have 1 pi over 3. And so pi over 3 about here, so it'd be here. I'll have 2 pi over 3, so it'd be about there, 3 pi over 3. And then we also could have like -1, -2, -3, and so we'll have -1 pi over 3, -2 pi over 3, and -3 pi over 3. And so this is really all you do when you're graphing this, is you slowly just practice. So here we have it go up. We can also have it come down. And so here, just all it does is make just a nice little line. Okay, so it makes a line. So the line, and here, this would be angle pi over 3. Theta here is equal to pi over 3. All right. So here, theta equals to pi, we just put this line, right? So this line right here, theta equals to 3 pi over 4 would be this line. Theta equal to 7 pi over 4 would be the same one as the one before. And so it just creates lines. So let's look at this. This is the first thing we did on, I think it is. Hold on, let me double check real quick. No, we didn't do that. No, it's the second thing we did, right? Remember how we got a circle? Remember what we got? We got a circle centered here. And we had ourselves a circle. Okay, let's see if we can show it by actually now sketching this. So this was part B from 8.1 from our last example. And so now we're going to find it using polar coordinates. And doing that, we're going to just slowly build this up. Okay, so let me have all the pre-calculated data in front of me. That way you don't have to wait for me to think through it in my head. So let's do this. So here, we're going to do theta. Let's do the pi's. Let's do pi over 4. We'll do pi over 2. We'll do 3 pi over 4. And then we'll do pi. And then we'll look at what happens when we're at 5 pi over 4. Okay? And that should be enough to get what's going on here. So when r is 0, sine of theta is 0. So 2 times 0 is 0. So my first point is 0, 0. My next one is pi over 4. So if I plug in 2 times pi over 4, I get square root 2 over 2. So this is just square root of 2. So 2 times square root of 2 over 2 is just square root of 2. So this is square root of 2 is my radius, and pi over 4 is that. And let's go ahead and plot these points as we get them. Pi over 4, I'd be square root of 2, so that's a little bit beyond 1, right? It's like 1.4, so let's put it right about here. Here when I'm at pi over 2, I'm at 1, so that'd be 2. So that'd be right here. So I'm at that 2. So it'd be 2 pi over 2. And then let's go ahead and 3 pi over 4. So 3 pi over 4, I'm again a half, or square root 2 over 2, sorry. So square root 2 over 2 times 2 give us square root of 2. So this is square root of 2, 3 pi over 4. And then here at pi, this is again 0, so this is 0, so this is 0 pi. Now if I'm at 5 pi over 4, I'm at negative square root of 2, right? And so let's go and write that negative square root of 2, because this is negative square root of 2 over 2 times 2 will give us negative square root of 2, and then this will be 5 pi over 4. And let me show you what's happening here. So we go here, we go here, we go here, we come back to about a little bit greater than 1, so about here. And then we come back here, and then here, if I'm at negative square root, so here I'm like here, and I go negative square root 5, well that just ends me up here. And so what happens is I'm slowly crunching through this, I'm producing these values, which produces a circle. Well, if I drew it a little bit more correctly, it'd be a circle around the origin here. And so let me show you how to do this in Desmos. Alright, so let's go ahead and do this. So here we're just going. Alright, so I had something a little bit further along. So let me shrink that window so it works better for us. Alright, let's go ahead and do this. Shrink that window so it works better for us. Alright, here we go. So let me make sure this is my field of range. It's right here. Alright, so here I'm going to type in r equal to 2 sine of theta. And most of this you're going to use a graphing calculator, especially for the online course. And notice here we get our circle nice and clean. But notice this isn't super useful for us. So here it's going from 0 to pi. It's going to guess what it wants. That's okay. So if you just click here on this little button when you're at Desmos.com and just click this from here to here, ta-da, this will make a lot more sense, okay? I'm going to be doing in radians for now, and so here's your options. So it's just this little anchor. So here, this will make us a lot more sense. So this produces, as it's drawn correctly, our thing. So notice here at pi over 4, I'm at square root of 2, 2, and then it calculates each and every one. So all we're doing here is we're just doing each and every one. Now I'm just doing like pi over 4 just because that's what I have on my paper. Sometimes you're going to do each and every tiny step. So you do like pi over 6, pi over 4, all this. Or you can calculate, or here we're calculating, it's calculating, you know, probably hundreds if not thousands of points in order to produce this, okay? But that's all you need to do is you just plug it in to whatever your equation is here. All right, so let's do it again. All right, with something a little bit more complicated. So what was this one? This was our third example. Okay, this was our third example. So let's look at this. Zoom on in. I had to remember. So this was part C. And remember, part C ended up being awful. It was like x squared minus 2x plus y squared, all quantity squared, equals 4x squared plus y squared. What a mess, right? But if we graph it using just polar coordinates, it ends up not being so bad. And once again, we're going to be using 0, square root of 2, or 2 square root. You know, in fact, in this one, let's jump in even more. And we'll just have the computer do the rest for us. So let's do that. We'll do pi, 3 pi square root of 2, and then 2 pi. That should be enough for us. All right, so let's slowly work through this. So 0. So r is equal to 2 plus 2 cosine theta. All right, so let's go ahead. So here I'd have 2 plus cosine of 0 is 2, so it'll be 2 plus 2 is, so this gives us 4. 0 is our first point, so let's go ahead and put that right in here. Oops. So 4 is 0. Here, plus 0, because 2 times pi over 2 would be 0, so this is 2 pi over 2. Here, what we have, we'll have pi. So this would be 2. This ends up being negative 1, so this is minus 2. So 2 minus 2. So cosine of 1 is negative 1. Times 2 would be negative 2. So 2 minus 2 would be 0 pi. And then here at 3 pi over 2, here would be right here. Once again, this would be 0. So 2 plus 0, because this is 0 for cosine. So 2 plus 2 times 0 will give us 0. So 2 is our radius, and then 3 pi over 4. So you just plug in this into, so we're just plugging this into this, and that will produce 2. Plugging this into this, and that produces 0. We plug this into this, and that. And so we're just doing this one step at a time as you would normally calculate it using if this was x and this is y, and you just crunch through the numbers, getting your y's and x's. Okay? So we're going to be doing the same relative thing like that. So here we get pi over 2, sorry. And then here we'll have 2 pi. This again is 1, so it'll be 0 plus 2, so this will be 4, 2 pi. And so if we just roughly graph that, so we're going to start at 4. Here we're going to be at 2. Here we're going to be at 0. And so it comes in, comes around, comes like this. And then it comes back, and then it heads back to 2 at this point. So it comes out, gets bigger and bigger, and comes in like this. And so these are called Cartroids. So you gotta spell that right real quick. There it is. See? So this is called a Cartroid. Why? Because it kind of looks like a heart, right? So this kind of looks like a heart. So that's where the name comes from. And so notice here, another way of kind of looking at this is here, if I sketch this, this is pi over, or this is pi, right? And this is 2 pi, and this is 0. And here we have our 1, right? So here at 1, and so cosine starts here, so it starts plus 2, slowly goes down, comes in to 0, then comes back out as I go to 2 pi. And so you can kind of see here, if I had my point here, this is point here, this point here is this point here, this point here is this point here, and every point in between for each of the angles you could kind of draw. This length here would be this length here, this length here is this length here, this length here is this length here, and so forth until you come in to 0. And so you kind of just bam, bing, bing, bing as you go along this, and then here, 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 here. Okay, so this is kind of how it gets built up. Okay. All right, so let's do another one. All right, so this is cosine of 2 theta. All right, so how do we do this? The same thing we've been doing before, as we've just been running through it. And so instead of using this, I'm going to switch gears. I know I put it here, I made the notes, but why are we switching gears? Let's go ahead and swap gears, and let's go ahead and use this concept here to graph it. So here, cosine of 2 theta is going to be, we'll have pi, we'll have 2 pi, we'll have 3 pi over 4, we'll have, or 3, we'll have pi over 2. And notice our graph will come down, hit -1, come back up. And so we'll have 1 rotation, and then it'll come back down, hit -1, come back up. Remember, because here it's 2 cosine, so we're moving at twice the speed. Now, if I use this to graph this, I'm going to start here, and notice here, I'm going to be here at 1. I should be at 1. Yes, so I'm here at 1. So let's go ahead and zoom on in a little bit. So here I'm going to start at 1, and by the time I get to pi over 2, I'm going to shrink back down to 0. Hold on, I'm doing this. Here, as I come in, as by the time I get to pi over 4, I come into 0. So here I come in, hit 0. And then here I am see if I can draw this very correctly. Then here I'm going to have negative values. So it's going to negatively come out all the way up to pi, where it goes back to, or pi over, oops, hold on. Let's see if I can draw this slower. All right, so let's be very clear here. So this. All right, so it shrinks in until I'm at pi over 4. All right, then here I'm at negative values, right? So here I come in, I'll be at negative values until I hit -1. And so here, notice here, instead of going this way, I'm coming in this way until I hit negative, oops, I overshot. I hit -1. All right, so here, these values are these. Now I'm going negative as I go along this, because I'm coming in negative here, come here, and then I'm going to come in, these values are going to slowly become positive until I hit pi over 4. So right here, then I'm going to have positive values here until I hit pi, which I'll be 1 again. So here I come into 1, and then these values slowly get smaller, and then I become negative again, and I come out through, and then come up here. All right, so I get this flower thing. All right. I know that's a little bit hard to follow, so let me do it. Let me do it one more time, a little bit more straightforward. So here, from 0 to pi over 4, I'm doing this. Right, so I'm coming in, and I'm going down to 0. From this, I'm now negative, and so I'm doing this. So this part here is this part. Let me do this in different colors. Let me do it in slightly different colors. So this part here is this, and this is this. Let's go ahead and choose a green. So this part here would be this part here. Because remember, it's negative values up. So here, but I'm actually ending up negative. Let's choose this, make this nice dark green. So here's the dark green, and then so forth. Okay? And so it just builds up slowly until you build this. All right. So that's how we do that. Now, most of the time, you're just going to have the computer do it for us. So let's go ahead and have the computer draw this for us. So let's just write this as, this will be cosine of 2 theta. And so it looks like this. And so that's what we got by using, so if you can graph this right here, you can kind of use it to graph this. Now that's, I admit it takes a little second thinking and a second practice. However, there are pretty set things for us, okay? So let me show you the set things. Let me clear out some memory real quick. So let me just, I cut the video so you wouldn't have to watch me export everything. So here's some common polar names and curves. So let's go ahead and look at this. So here we have circles and spirals. Oops. Let me do this so I can write on this. There we go. So we have circles and spirals. And so here it's a circle, and then here, if you have it up, we can have, so these are just a bunch of circles, and then here, if you have a theta, they'll spiral out and get larger and larger as theta gets larger and larger. So these will continue to go and go. And these depend on this. You have what we call limicons, and so these are limicons also. Some of these are cartroids, so this is a cartroid, this is a limicon. And these are usually a plus or minus cosine or sine of theta. So we'll look at some of these. We have roses, we looked at some of these, and so here we have a 4-leaf rose, here we have a 3-leaf rose. So it's n-leafed if n is odd, it is 2n-leaf if n is even. We kind of shown this before. This is, and these are quite complex, and these are 8-figure shapes, and so here if you have these, these go on and on and on. You don't really need to know how to do this. All you need to know for this course is roughly how to sketch this by hand, and then how to do it in the computer, okay? But this is a very useful chart that I have on the notes just in case you want to use it. All right, so let's do the rest of these. So let me talk about a couple things real quick. So let's talk about symmetry. So here, oops, not what I meant to do. Let's get rid of that. So if I can replace theta by minus theta, it'll be symmetric around the polar axis. AKA, as I go positive, it'll be the same thing as I go negative. This is really kind of symmetric around the x-axis, as you can see. Here, if I can replace theta by minus, it's symmetric around the y-axis, right? And here, if I can replace r by negative r or theta by plus theta, the graph is symmetric around the pole. So here, it's symmetric this way. Right. So let me kind of show you what they want us to do for that. All right, so this should be an equal sign, sorry. All right, so let's look at this for a second. Let's look at this for 1 second. That's what we have here. We have this, and so let's go ahead and graph. So cosine theta. So let me draw in cosine theta. So it comes in, comes down, and then hits 0 at pi. Okay, and then it comes back up into this. And so we're going to be using this to graph it right now. All right, so it's 1 plus 2 times this. So we're going to start at 2. And then by the time we hit pi over 2, we're going to be at 1. So it's going to slowly crash into 1, right? Because here, this is my cosine of theta. And I'm going to add 1 to that. So if I add 1 to 2 times cosine theta, let me kind of draw that for you. So it'd be, so here I'd have a line at 1, right? And here it'd be at 3, and then here's that negative 1. It's going to do, so it's going to come in, go down, come up, still bottom out at pi, right? And then come back in and up to pi. And so it's going to look like this. And so it comes in, comes around, and then here it, by this, it becomes negative and then comes in here, right? So we know this is, however, cosine of is an even function, aka cosine of this is equal to cosine of negative theta is equal to cosine of theta. So here, if I draw the other part in green, it's just going to be reflected across that. And so this is how it ends, right? And so this is how it ends, or we can just use this. Let me use the lighter green. Let me use the lighter green so it's a little bit more apparent. And so here, let's just use red. Give me red. Thank you. Whee! Now that I've done this one too many times, that is not a very deep red. There we go. This is a lot more clear. All right, so here, this will be this half of it. And so we don't actually have, if we meticulously solve the first half of this and get this, we can just use symmetry to say, all right, this will be the second half of this. And so that's kind of what they want you to get out of this. Now the last part, they just don't accept, they just assume you're not going to be able to do this, right? They say, all right, just graph this using r equals 2 cosine theta. And so I'm going to graph it in Desmos, and then I expect, and then just for the notes, just kind of make the graph in Desmos, and then sketch it on here. And I'll sketch it on here with you guys, okay? So let's look at this. So let's do these more complicated things. So here I have r equals 2/3 theta something, or 2, oops, hi, it did not go all the way through. So r equals cosines of 2 theta divided by 3. So here we have the 2 theta already. All we have to do is just divide by the 3. Not quite what we wanted. Let's try it again. Nope. Please make sure your computer's doing what you want it to do. And there we go. So let's look at this happiness. Ta-da. Let's go ahead and zoom on in. So this is what this thing looks like. Kind of complicated, right? And so it's going around and it's doing this. And so what it's really doing is it's starting here at 1 and it's coming in, going around, 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 and then goes around. Okay? It's really what it's doing. So let's go ahead and try to sketch that. And so here it's going to start at 1. So I'm going to zoom. Let's go ahead and just switch. Hi. Why do I have no, why is this not working? Okay, now it's working. I was like, why is this not working? All right, so let's get rid of this and get rid of this. Let's just call this 1, okay? Just for the sake. So this is 1. Just that gives us more room to draw this thing. So what it does is it comes in, comes around, comes up, comes around, goes out. So that's half of it, and then we'll draw the other half, which is comes in, oops. Trying to think of the best way to draw this. And then the other half will come in, comes around, and comes in. Alright, so that's not a terrible sketch of it. I mean, granted, this looks way better, right? But it's close enough for what we're going to do on our papers. Alright, so now it wants us to draw a family of these, and so we're going to just change scenes and see what happens here. And so this is just best done on the computer. So let's do that. So we're going to just use 1 plus c sine. Alright, so let's just do this. So we 1 plus, oops, hi, not what I wanted, plus 1, and then we're going to have sine, and then we're just going to have boring old theta, nothing too fancy. Alright, so this is 1 plus sine theta. And so we're going to do a family of this, so we want to do for 1, 1.5, 2, 2.5, and 3. Okay. So I'm just going to copy this, and then I'm going to show you this, and then, so we're going to swap that to 1.5. Do it again for 2. Let me zoom on out so we can see what's going on here. And then we're going to do it again for 3. And then the last one I needed was 2.5. I forgot to do that one, so let's go and do that one. Alright, so what do we have here? So this, slowly, as we notice, let's go ahead and do this slowly. It starts off as a heart shape, and then it gets a little bit bigger, a little bit bigger, a little bit bigger, and a little bit bigger. So that's what we're looking at here. So let's look at all these. And then we're going to just draw this on our papers. And so here's a family of solutions as we increase that. So the first one, remember, right? Let's go ahead and do this. This comes in, and then it hits 2, comes back out, comes in like this. Here is the next one in red. It's going to hit 2.5, so it comes in. So this one had a little bit of a loop. This one had a bigger loop, and notice that loop will hit 1. And then this will come all the way out and hit 3. And that's good enough. Just draw like the first 3 on your paper, and I'll give you the idea of this. And they don't have to be nice. Just kind of draw them. Alright, so these are family solutions. So polar graphs can get very complicated in the sense that they're all that, but all we're doing here is remember, all we're doing, let's just take this for example, is this just plugging in here, and then it's just calculating, okay, well, that's 1 plus 0, this is 1 plus pi over 2, this is 1 plus 1, and then each angle is just calculating this for each one of these. And notice as we get larger, here, now I produce, when I'm heading out this way, I'm actually producing negative values of r. And so, and I believe that's why your book is using the more loose terms of R. That way it's easier to graph these things, so you don't have to retranslate them into what it's going to be. All right, so that's the end of section 1.8. And so, yeah, that's the end of the video.